Hello and welcome to Cambridge Skeptics. Sorry for the small technical difficulty there. Cambridge Skeptics are a not-for-profit community organisation founded to promote science, positive skepticism and critical thinking skills via public engagement. And tonight we are going to have what I think is going to be a very interesting topic from Sam, who is going to be talking about the way that statistics are not always what they seem. So I will hand over to him and he'll get the show on the road.
Thank you, Andrew. I'd like to start, I think, with possibly some of the first things that people come across when doing statistics, which is summary statistics. Basically, things that are used to describe data in a very broad fashion. So, Chris, if you want to describe a set of data and you had two statistics you could use to describe them, what would they be?
My favorite two statistics. Thank you. I've been putting a lot of thought into this.
Which would you prefer your go-to?
So I would go with some sort of measure of central tendency. So a mean.
Yep.
And a measure of spread. So a standard deviation.
Sounds good. Yes. And of course,
there you go.
Was that what you were going to say, Andrew?
That was exactly what I was.
Yeah, exactly.
That was exactly what I was looking for. So thank you. And of course, these two things tell you everything you need to know about a data set, right? Yes. I am about to show you my favorite set of graphs in the world, which is not a phrase you probably hear very often, but you'll see why once they come up. This is the Datasaurus dozen. And they're called the Datasaurus dozen because it's Datasaurus plus a dozen other graphs. And the thing that they have that brings them all together is, from a summary statistics point of view, they are identical. Okay, there's basically, it's a set of points. They've got an x-axis, they've got an x-coordinate and a y-coordinate, and all the x-coordinates for all the graphs have the same mean and the same standard deviation, as do all the y-coordinates, and the two data sets have the same correlation. So from a how related to each other are they appear to be the same. So from a summary statistics point of view, these graphs tell us it would appear to be the same.
They look the same to me, so I mean,
yeah, but that's the problem, is that quite often I think we get presented with, on average, blah, things go up, and that's not to say that those aren't useful. They are useful, but if you want to mislead someone through statistics, or if you are doing analysis, this is a serious problem, because actually it doesn't tell you, like, those summary statistics, yeah, they're good, but they are at best a starting point.
So if I'm plotting my data and a dinosaur comes up, I should be.
I'd be impressed, actually.
I'd be really impressed. But I think to a great extent, like, the answer is on the page as to sort of what we can do to help ourselves. So what can we do to help ourselves from being misled?
I think the fact that you've got graphs there, so just rather than just showing values and things like that, show that it looks like a dinosaur, impress people.
So visualize your data.
Yes, visualize your data.
Absolutely, yeah, and it's the first thing I do if my graduates are like struggling with figuring something out. Plot it, make a graph, and you'd be surprised how often
a dinosaur comes up.
A couple of extreme values will answer it, but also sometimes actually the problem isn't the whole lot. The problem is a section or a segment or just a small handful. It's not everyone. It's just it's not everyone. It's just this group here or something. Though admittedly, I have to say I have not come across too many of these.
Just the one dinosaur.
Just the one dinosaur. But You have no idea how often I use this at work. It's odd, like it's the first. I have a whole thing of like handy graphs for showing people things, and this is the first slide because this shows what statistics, whilst useful, really do not tell the whole picture. So Simon has just said, you know, an actuary once said to me, yeah, if you can't see it in a graph, it probably isn't significant. And I can't remember who it is. I think it was it was on the XKCD that you know, ideally you want your tests to be so good you don't need statistics. I think it's the same sentiment. Like, you know, if you need to do a test, well, it's not if you need to do a test, but yeah, if there's a really clear difference between two things, quite often you don't need statistics, and the summary statistics, I think, will often tell a good enough story there. But sometimes, of course, they are useful, and sometimes they are very helpful. So, in one of the things that that has always bugged me about some of the conversation around climate change is quite often that people go, oh, climate change can't be real. It snowed 15 times last year. Or something like that. So there's a there's also this phenomenon. I don't actually know what it's called, but basically it's that actually just because the mean of two things has changed doesn't mean that the distribution overall has changed. So in this case, the kind of the new graph here has a higher mean like this, and this is sort of representative of what happens with climate changes. Actually, the average temperature has gone up, but the variance has also increased at the same time. And so strangely, what that means is actually you end up with more sub-zero temperatures, really weirdly. But what you also end up with is a lot more really high temperatures. This obviously is like a theoretical scenario, but this is sort of indicative of what you see in a lot of places, particularly sort of in the central continents. Is actually the temperatures going up, but the variance is increasing more as well. So you end up with actually more extreme negatives and a lot more extreme positives. And so this
is why we changed from calling it global warming to climate change, to make this sort of difference clearer, I guess.
I think so. Plus, also, it doesn't mean that everywhere is getting warmer. Some places are getting colder, but globally speaking, it is getting warmer. But this, like, to me, as a statistician, basically going, oh yeah, it's getting hotter, and then someone going, oh, but, and then citing some small extreme number of cases, like, you know, the kind of extreme negative cases, as if that means everything, without the understanding that actually, no, those two things are not mutually exclusive. Like, you can be.
But wasn't there a US senator that took a snowball?
Yes.
I mean, and that's completely ignoring the whole, like, a single case doesn't mean anything for statistics kind of structure. But anyway, that's kind of summary statistics. So yeah, they can be useful. But you really got to keep them in mind and just be careful, because it's incredibly easy to be misleading, and it's incredibly easy to focus on one thing and not take the overall into account. Graphing stuff is really useful, and particularly if you're doing it two-dimensionally, because there's a lot of things that do really come out of the woodwork once you can actually look at stuff when comparing it to other stuff, which I realize is a really kind of reductive way of putting it, but it is important.
Is there a particular type of visualization that works better than others, or is there a first one we should try?
No, it's horses for courses. It really matters what it is you're trying to look at. It depends also on the volume of data. But basically, you have a 2x2. If it's a relatively small number of cases, just plotting it as you saw in the data source graphs is useful. Otherwise, you might have to do like a heat map or density map if you've got a lot of cases. But yeah, start there and work on, I think.
Yeah, I've heard people say the scatter plot is the most powerful tool.
Yeah, it's, if nothing else, it's your first go-to. Yeah. Now, the statistic we used is kind of at the end of the last video, kind of highlights a whole issue around sort of framing the question. This isn't so much around the statistic itself; it's about how the statistic is used. And so, yeah, I think it was the weekend before the last live stream. Laura Boba had come up and said, "Oh, there are 365,000 missing children in the US." There weren't 365,000 missing children in the US in 2021. There were 365,000 missing children reports in the US. 95% of those were kids just running off and their parents not knowing where they were, who came back, or kids that had been kind of taken by one parent in a parental dispute. But it's a real favorite of the conspiracy theorists to take a statistic that doesn't quite, take a statistic that is true and then use it for something that's slightly different and slightly misinterpret it and slightly misunderstand it, in order to be able to make outrageous claims that back up their view of whatever.
It is a shocking number if you don't know what it actually refers to. Or...
Oh, absolutely. And this has been happening for a while. So I apologize for the quality image. This is the best quality image there is. But you guys might remember this advert from 2007. So it's released by Colgate. More than 80% of dentists recommend Colgate toothpaste. And this was...
Do we get to guess how they came about this number?
Yes, please. In fact, and well, I mean, first off, the Advertising Standards Authority forced them to remove it. But I think that most of us would interpret that to mean this, or at least anyone would reasonably interpret it to mean 80% of dentists recommend Colgate and 20% recommend someone else. So, yeah, Chris, how do you think they came about this number?
I have no idea. I guess you would draw up a sample and survey your sample.
Yeah, Andrew?
I'm trying to. Obviously, it's not what's on the screen. It wasn't that they asked 100 dentists and 80 of them said Colgate and 20 of them didn't. I'm guessing it's obviously something else.
Is it
I don't know.
the brand they sell at the?
Yeah, I feel like it's maybe. I'm coming back to the taste test we did at yours, Sam, where maybe they were given one thing and then said, "Do you like this one better than this lump of coal you can chew?" And 80% went with it. I don't know. Oh, we have a suggestion in the chat.
Excellent.
Yes, ask if they recommend toothpaste like Colgate. Yeah.
That's closer, I think, but it's
nice
quite
one,
simple as to what do they...
So give us a clue. What was the data collection method here?
Well, let me give you a little mock-up of what they did. If it loads. There we go. You didn't have to only recommend one toothpaste.
Okay.
It was, well, actually, how many of these which of these toothpastes would you recommend? Dentist say it's like, oh yeah, Colgate's fine, Sensodyne's fine, and Aquafresh is fine. Yeah, I'm not.
100% recommend Aquafresh.
But that's the point. Like, any reasonable person would see, oh, someone recommends this. Well, they recommend it to the exclusion of other things.
Yeah.
Yes.
But no, actually, all they've said is it's not so much 80% of doctors would recommend Colgate as it is 80% of doctors. Geez, dentists. Dentists are fine with Colgate. That's probably a better description of it. But however they phrase the question, it sort of So the methodology used to calculate the statistic matters immensely, because here, the kind of the end result is misleading. And in this mock-up, actually, Aquafresh has 100% recommendation, and yet if we saw 100%, people go, yeah, but not my doctor doesn't recommend Aquafresh, do they? Do they use it themselves? the real question would be like, how many dentists? Sorry, I keep saying doctor, don't I? How many dentists would actually use like?
Yeah, what do they use?
But that's the question. But that's not.
Are they the best people to ask about this? I mean, have they done chemical analysis on various different toothpastes?
Well, that's a whole separate question. That's like, are they, or is a dentist an authority on what is a good toothpaste? But then we're getting to like whole arguments from authority things and whether or not we should trust them. Because like you say, they don't know what goes in. I suppose they see an effect, but is it that actually? Well,
do they? Would they notice? Do they?
Well,
I don't think my dentist ever asked me what toothpaste.
No, yeah.
I don't know. But maybe we're getting on to correlation versus causation, which we will.
I've got my spurious correlations website all ready to go. So,
if you could not do that because I've used that.
It's all right.
But I have the COVID pandemic has been a fabulous, truly fabulous source of terrible data presentations, and
I'm glad you're happy about it. Yeah.
It's produced some of my favourite worst graphs of all time, and so I want to take you through a bunch, and I want you to tell me what's wrong with them.
Are there any that look like dinosaurs? Otherwise,
Yes, if they don't, ask me what's wrong.
I'm afraid not. But some of them look like the websites might have been written by dinosaurs. So let's
go back to Nature News, are we?
Well, it's all kind of presenting results, framing the question. It's all around actually, the issue isn't the statistics. The issue is the communication of the statistics and not communicating clearly what the actual meaning is. It's Sam Harris in his essay titled "Lying" on what is lying defines it as to deliberately mislead someone that expects honest communication. And to my view, like all of these are lying because they are deliberately trying to mislead people who would expect honest communication. So, graph number 1.
Okay, it's small. That's misleading.
Okay, how's it misleading?
I can't see it.
Chart represents the most impacted countries over the past 15 days and the number of cases over time. The table below also represents the number of deaths and hospitalizations in each of those impacted countries. Okay, so...
Yep, so you've got 5 different counties.
Okay, the colours are counties, are they? Okay.
Things are improving. Deaths are down.
Okay.
Andrew's certainly trying.
I'm definitely trying.
It's too small. I can't see it.
It's too small for me, yes.
So on your thing, there should be a full screen button on the bottom.
Ah, yes. Okay, I've got that. Yeah. Okay.
I thought we weren't touching the buttons.
Yeah. Not after last time. Okay, so
if anyone in the chat can see what's happening, wants to try and call it out, then I'll stick them up if they got it right.
Well, it definitely looks like looks like things are going down over time, and so it's the table below also represents the number of deaths in hospital.
It's not in the blurb.
Okay.
Can you make out the bottom axis? I cannot make out the bottom
It's
axis.
dates. So 28th of April, then the 20th. Oh, it's going backwards. What? No, hang on.
Bingo. Yeah.
Those dates are going backwards.
Yeah, let's go backwards.
Dates along the bottom, for those who can't read, go the 28th of April, 27th, 29th, May 1st, April 30th, May 4th, May 6th, 5th, 2nd, 7th, April 26th, May 3rd, 8th, and 9th.
I'm not sure that's how dates work.
It's the date order. They've just basically gone, you know what? We want to show something that goes down over time. We'll just order them by overall caseload rather than by date.
Wow.
So any reasonable person looking at this graph
That
will
works.
think, oh, things are improving. And you know what? Actually, the highest number of hospitalizations is on the third day, and the lowest number of hospitalizations is on the last day. But it's still misleading. It's still really confusing because actually the 1st of May, the 4th of May, which are kind of in the middle, actually, it's just a terrible example. They're deliberately structuring it to try and mislead the public into thinking actually things are really, really on the up and up, or the down and down, I suppose. But it's this is not how data should be presented. You're going to be, if your job is to inform the public, you should not be doing this.
And I think the very fact that me and Chris were knowing something was wrong with the graph and actively looking for it, and it took us a while to get there, really proves your point straight off. If someone nobody's going to look, they're going to look at that graph, they're going to go, oh, the bottom values is dates, the other axis is number of cases, it's going down, great, that's it, that's all people are going to pay attention to.
Yeah. So graph number 2, from Russia, with love.
Okay, well, numbers seem to be working properly this time, so that's a good start.
What are those? What are the green numbers at the bottom?
Yeah,
what the hell are those?
That's I believe that's changing cases.
Oh, okay.
Okay, all right. So,
all right. Yeah. Okay.
So it looks to me like cases are increasing. I'm guessing the red is probably something like deaths or something. It looks
that's total. Yeah. So sorry, I think green is number of deaths change that day.
Oh, right. Okay.
Number of deaths. I don't read Russian.
Right. So okay. So it's not okay. So there weren't 2,337 deaths on the 31st of whatever month that is. That's the total number of. Yes. Okay. So it's keeping a track of the total number of deaths rather than deaths per day sort of thing.
Do the numbers in white mean anything?
That's just the day of the month, I believe.
Okay. Hey, Dr. Osiris is here. Oh, Sheldon says it looks like it's logarithmic.
Yes. So, yes, I missed that. So if you look at the last day, 2,300 deaths. That's basically twice as many as the 4th to last day. Except, of course, that's... if you're just looking at the graph, you go, things are increasing a little bit. Things are mildly increasing. No, it's doubled in 3 days. And yet, again, from seeing that, you wouldn't get that impression. It's, again, another deeply misleading graph that just isn't an accurate representation of the data. And like you said last time, Andrew, if you're just glancing at it, if you're not taking a close look, you'd be kind of like, yeah, things aren't great, but they're not terrible. Things are terrible in this graph. This is not a good graph. Okay. Number 3.
It is good. It looks nice. I like it.
This one is a little more complicated.
Oh God, we haven't got the last 2.
So, no. So
we need all the help we can get.
I'm just going to talk through this one because I think just getting you guys to stare at a bunch of graphs for a while probably isn't great YouTube.
That's what I'm here for.
I don't know.
So if you're looking at this graph, who are the worst? Actually, look.
25 to 40 for 9-year-olds.
25 to 49-year-olds are responsible for the bulk of COVID cases.
Yes.
So 25 to 49-year-olds are the people who aren't, behaving themselves properly and are risky behaviour, getting COVID all over the place.
But they're not the
That's a big chunk.
That's But in the
Yes.
middle of that, yeah, but below that, you've got the 15 to 24, which I would say with the younger people.
But
Oh,
that's,
no,
that's a
Chris,
9-year gap. You've got like 20,
Yeah.
Chris
24
hit
years.
on there's 25 years in that.
You've got some
Yeah.
unusual bins there.
We have 15
Yes.
odd years, and you would expect like the number of people per year in the 15 to 24-year-olds to be pretty similar to the 25 to 49-year-olds. And so by presenting it as total number of cases rather than as like cases per capita, it paints a very, very different picture. 65 and older is, you know, a significant band, and yet actually it's, you know, it's still significantly small in terms of total number of people available. And therefore, like, the question is to, you know, per 25 to 49, or how, you know, per 100,000 25 to 49, how many of them have COVID at any given time. That's pretty, yeah, that's pretty misleading. The suggestion here, looking at this, is 25 to 49-year-olds are being reckless and getting COVID, much more so than everyone else. But actually, you start weighting it by the volume of the population, it kind of says, you know, yeah, the under 15s are good and the over 65s are good, but the rest of everyone else, basically everyone else that's economically active, they're all much of a muchness.
All the others are divided into around 15 age, and that one's 25.
Yeah, but it's
why?
But that's the point. It's another misleading graph. You take a glance at it, and you're not thinking critically, and you're not questioning whether, you know, what it means. You would say, yeah, 25 to 49s, they're the problem. But actually, you know, they're probably not materially worse than the age group above them or the age group below them.
What was the source of this?
Good question. Can't remember.
Oh, the European
Surveillance system.
Part of the European Centre for Disease Prevention and Control. Okay.
Sounds like some kind of evil AI.
Yeah. That's why we have Brexit. On that European surveillance system. And then the last graph I have is one that I saw, and I can't remember if it was Texas or Florida, and I haven't been able to source the original graph, so I've recreated it. And it's the number.
I'm already suspicious.
Yeah.
It's the number of COVID cases. Yeah, I think it's the number of COVID cases per 100,000. And I think this was over the summer. Maybe it was. Oh no, yeah, it's 2020. So
They've just flipped the graph, basically, haven't they?
yes. So again, this is another one where if you're not paying attention, you're just having a glance. Oh yeah, things have improved. Yeah, they maybe got a little bit worse recently, but actually things overall have improved. No,
It's upside down.
it's a negative. It's got a negative axis. Like, it gets worse as you go down. This should be flipped. It should be completely the way. Like, things are actually improving a bit, having been really bad. But this was I'm 90% sure it was Florida, 10% sure it was Texas. But this was how they were presenting their data for like 4 or 5 days.
Sure it was Colgate.
Called out by a bunch of news programs. Since seemed to have purged it. But it's just like the whole, like there's a whole question about like the statistics themselves, but it's not the statistics often that are misleading. It's the use, it's the presentation, it's how they are imparting that information. And let's be entirely clear with ourselves, on every, except with the possible exception of the previous graph, all of those other ones were deliberately manipulated in order to present a different picture to that which the data actually.
I think the last one must have been deliberately manipulated as well to have a different bin size for that age group.
Yeah, but there's a good chance some economists just went, "This is the standard age brackets."
Those aren't the standard age brackets, though, are they?
Oh no, it is.
Really?
Yeah, it's if you're going like as to like how economically active and like what purchasing habits are like that is generally how you break things up, and voting brackets as well, quite often broken up that way. If they are going to go more granular, they'll break up the 25 to 50s into 25 to 35 and then 35 to 50. But is that those are like some relatively common brackets.
Okay.
Anyway, Andrew, do you have your website open?
Oh yes, I can bring that.
Too bad. So, for anyone that doesn't know, spurious correlation is it spurious? Basically, Google
correlations, yeah.
And you come up with a brilliant website that will give you a bunch of really high correlation items which are completely unrelated. So in this case, this is with a 99.8% correlation. This is suicide by hanging and US spending on science. Follow each other like, I don't have a good analogy. Like a glove, that doesn't make sense. Like a glove. Yeah. And there's a bunch of these. Films Nick Cage in versus people who drowned in a pool. Or
I can see that more as a relational thing. The more films Nicolas Cage is in, more people throw themselves into swimming pools.
Yeah, and then a number of people have been tangled with bed sheets versus per capita cheese consumption. Also, I feel like Nick Cage, just as an actor, always adds something to whatever film he's in. Like, it doesn't necessarily mean his acting is good, but he adds something.
I think it's the something that's the question.
Yes. Kills people in swimming pools.
But yeah, and so quite a lot when it comes down to sort of, I'm going to say economics, but basically anything where we don't have experimental control, it's incredibly difficult quite often to determine whether A causes B, B causes A, they're both caused by some third thing, or actually they're not related at all, they just have this sort of this high correlation. And so this is one of the things where, like in science, if you're doing science per se, you need to come up with the mechanism by which A causes B. Like this is sort of a fairly important thing within the discipline of science. Is you can't just say, hey, these two things seem to be related, therefore one of them causes the other thing. And my favorite example on this is actually the relationship between drowning and ice cream sales is incredibly high. But we're not proposing that drowning causes ice cream sales.
No, ice cream sales cause drowning.
Yeah, and that's
you're not supposed to swim for half an hour after eating. Everyone knows this.
Makes sense.
Everyone knows that, even though it's false. But that is a classic example of that like what you're describing there is that as a myth is evidence of this. There was a whole issue of like actually kids are eating and then they go in the pool and they're drowning. But the thing is, you bring up.
Could have been kids were eating even if they didn't go in the pool.
Well, no, but the kids. It's not that the kids are eating, and eating is going to cause them to drown when they get into the pool.
Yeah.
The kids eating by the pool means they're by a pool. Like it's difficult to drown if you're not near a body of water. Even though, actually, it just means, yeah. And so in the ice creams and pool and pool drownings issue, of course, both of those things are caused by hot weather. Hot weather makes people go to the pool, and you can't drown if you're not near a body of water, and it makes people buy ice cream.
And it makes Nicolas Cage make films.
Yes. I Can Science That's asked a question in the comments about correlations, Sam.
Yes, so...
Are we going to bring it up? Ooh,
yeah. Fancy.
Israel says there's a correlation here. Can we find a relationship? Yes, yeah. So that's, I think there's a...
That's something we talked about in our Things Skeptics Say, isn't it?
Well, I was about to say, what was that quote from... Oh, I can't remember who it was. But, the most interesting noise in science isn't eureka. It's, that's funny. No, because it is. And that's the... it's... I work in like business analysis, and there's when it comes down to like a gut instinct, or when you see two things that look like they might be related, that doesn't tell you what you're seeing. That tells you to start looking. And it's at that point you need to start digging around. Like, is there any supporting evidence? Can you see variation between the two? Do they seem to match? Could you conduct an experiment? is there a reasonable mechanism by which A may cause B or B may cause A? But the only way to really check that is an experiment.
So we need to heat Nicolas Cage up and see if he makes a film.
No, we need to feed him ice cream.
Oh, feed him, yes.
So this is...
That's a good correlation.
Well, so I work in insurance, and this is basically, hey, what happens between customers lapsing, i.e. not renewing their policy, and the price that we offer? Oh, shit. Sorry. Bother. No. I've realised I've not loaded one of my slides properly. Let me just...
Hang on. Andrew will distract them with a cat.
I'll distract them with a cat. Quick, come here. Be distracted.
How on earth did you get down there?
She's opening various web pages.
Okay, so
the cat.
So basically, no, sorry, I fixed it. It's all fixed.
Hang on, no, we've lost interest now. We're
seeing
what the cat's googling.
Yeah.
I mean, are you cats? Because that seems like pretty cat behaviour.
Yeah.
Can't
say.
Huh, yeah. Are you new to the internet? Because that's what people are here for.
My cats have more followers on Instagram than I do. Like, don't worry, I understand the internet. Also, they're freaking adorable. Anyway, so yeah, can you conduct an experiment? And so, if we want to know if, in a very basic scenario, if we want to know, hey, does price actually result in people lapsing more or less, depending on what price we charge? We can conduct an experiment. And so, if we were to put prices down, and this is something we do, suddenly, if it follows, great. If it continued to carry on, the implication would be, actually, no, you know what, price and lapses are completely independent. Completely independent of one another. Obviously, that's not the case here. Don't think anyone would expect it to be. But there are some interesting elements. So in my world, there's just been some heavy regulations coming in January. People are much less sensitive to price now than they were. And so you've got to repeat a bunch of experiments over some of our assumptions, because actually those assumptions may no longer hold true, and certainly if they do hold true, may not have the same magnitude of effect that they used to. Anyway, we're going to get to my favourite paradox. Yeah. And it was on the show notes. Do either of you gents know what Simpsons paradox is?
I've been meaning to Google it. I didn't get ready to it.
Andrew?
I don't know. How they keep putting more money into the show, but it keeps getting worse. No,
that's just burnout. Good man, Simon. Sorry. Simon's made a very important point. Still have milk in the tea, unless it's Earl Grey. Never have milk in Earl Grey tea. Erica, if she were here, would decry that, but every good Englishman knows you shouldn't have milk in Earl Grey. Anyway, Simpsons paradox is like one of the bane of my existences. Basically, it's that because you can have different volumes of people and data in different sort of subpopulations, and because the overall rate of things may differ between two groups and differ between two different sets of populations, actually a relationship may look like it goes in one direction at one level, and then when you break it down to groups, it may look like it goes in the opposite direction. It was... Which I realised...
I understood that.
Can you put that on a graph for me?
Yes.
There's graphs later.
Okay,
Awesome.
good.
I'm here just for the graphs. Are there any spreadsheets, though? Because,
What do you...
Isn't that a spreadsheet?
yeah, fair enough.
Those are the closest you're going to get to like a proper spreadsheet. So this is possibly like the standard example of Simpsons paradox. It's 1973, University of Berkeley admissions numbers. And basically, you look at this on an aggregate level. Women are admitted. Women admitted 30% of the time that they, or 30% of female applicants are admitted, whereas 45% of male applicants are admitted. Therefore, the University of Berkeley has a gender equality issue. Yep, clear?
But if you look at it by departments.
Yes. So if you look at it by department, Department A has a significantly higher proportion of women admitted. So does B. C is higher. D is higher. F is higher. E and C are down a bit, but a bit.
Not
like
much,
overall, you would look at this and go, actually, the women are doing better.
Yeah.
But here's the thing. These top two departments, which have the two highest overall admissions rates, 64, 63% versus below 50 for all of the others, these top two departments represent half of male applicants.
Right.
But they only represent 7% of female applicants. And so looking at this, you would say, well, actually, the problem isn't that women aren't being admitted. It's that there aren't enough women applying to the departments that have high admission rates. Or conversely, the departments that women apply to are being underfunded and therefore can't admit as many students. Or possibly, it's nothing to do with gender at all. But the issue isn't that actually you need to bump up and support female applicants. But this is it. And so I think from memory, I think the initial Simpsons paradox showed that was actually on like death row in like Tennessee or somewhere. And what it showed was that black men got put on or got sentenced to death row more frequently than white men did. Yet, if you grouped a black murderer versus a white victim, actually they were less likely to get death row, and a black murderer versus a black victim, they were less likely to get death row than a white murderer. But because the murderers of black victims got death row far, far more frequently, and the vast bulk of black victims had a black murderer, actually that meant that overall the numbers, the numbers sort of skew. So
I think one of the things that really stands out to me from this side, derail you there, Sam, is how if you just took the percentages, you could basically make either case. So you could either say, you could quite easily take the total percentages and say, look, women are discriminated at this university. They don't get admitted anywhere near as high as men. Or you could take the individual departments percentages and say, well, no, that's completely not true. Women are very well supported at this university. In fact, in most departments, they're the largest number of percentage admissions.
And both of those would be true. And this is why it's complicated. And this is why you like going back to the graphs earlier. This is why breaking things down by 2 dimensions is important, because actually you tend to discover things like this. But where possible, break it down by 3. So here's an example. Pulled this. This isn't me. I'm not this fast. But this seems to show, actually, what you have here is a bunch of running times and weights that have been recorded by a runner. And actually, what it seems to show is that as you get heavier, you get faster. I think that's pretty clear, isn't it? So what's happening here? Given your new knowledge of Simpsons paradox.
I'm guessing that there's more. Yeah, it looks like there's more running going on when he was lighter, and fewer when he was heavier, and maybe the heavier have a more. There's more variation in the lighter time. The lighter time.
Maybe he'd been training for.
Yeah, so maybe there's some third thing that is related. So here I've grouped them into 3 different sessions. So you could be running for a while, then stop, continue working out at the gym and things, maybe get stronger, and start running again. And so over here, pretty heavy, but still relatively quick. And then here, actually, maybe as he got older, come back, and even though he's the same weight as he was before, partly because of a lack of training and partly because, you're just slower when you're older, actually his time is significantly longer, even though he's at the same weight. And whilst he still continues to improve as he gets lighter, he's still never quite as fast as he was at the same weight. And so then you have the same third stint here. And so by comparing this and the sort of previous graph, you can show actually the relationship is completely opposite depending on whether or not, sort of how you break it down, how you group it. And so for me, the definition, Simpsons paradox doesn't have a concise definition, but for me, the way that I use it is essentially that two variables can show a relationship which is opposite to their true relationship because they each have a stronger relationship with a third variable. So in the admissions example, the relationship was the the proportion of applicants to department by gender. Actually, there was a much stronger relationship between gender and department that they applied to than there was between gender and overall admissions rates. And so that department distribution was the third one. In this case, it would be something else like age. But basically, you have this third variable which is hidden, which can't be seen, which actually has a much stronger relationship with the two variables in question. So this was one of the first cases of forensic statistics in the US. It's a very famous case, and basically I remember the details now. I think a man basically robbed a store, got into a yellow car being driven and driven by a woman, and shot off into the distance. And so the prosecution basically called a witness who said, the man had a beard with a sort of mustache, it was a white woman with a ponytail, they were in a yellow car. And then they got a forensic statistician, not sure why that's a thing, to come along and basically ask...
That's a forensic everything these days.
Yeah. But to basically ask, how likely is it actually that this couple, the defendants who match this description, how likely is it that they are innocent? What's the likelihood that any given two sets of robbers had these characteristics? And so he went down and went, well, actually, 1 in 10 people is a black man with a beard, 1 in 4 people is a man with a mustache, and so on, and then multiplied them all together and just went, there's 1 in 12 million chance.
That doesn't feel right somehow.
So there's a lot of things wrong with this. I titled it False Independence because obviously, the likelihood of being a black man with a beard and then, it's not...
And not having a mustache.
Black man with a beard. Yes, exactly. The likelihood of being a black man with a beard and a mustache presumably is only slightly lower than being a black man with a beard. It's not 1 in 40, as this is going to suggest. Not when being a black man with a beard is 1 in 10. If you're a black man with a beard, 1 in 10. And with a beard and a mustache is probably 1 in 10.1 or something like that. And so, so several issues here. One is basically it assumes independence. These things aren't independent. Secondly is that it assumes no real knowledge of the local area. I think this was in San Francisco. Presumably, there's a lot of ponytails there. It's hot. People want to keep their hair off the back of their necks.
So you're saying it should be more than 1 in 12 million?
No, I think it's less. It's less. Those numbers are smaller. But also, if you've already assumed that there's a black man with a beard and a white woman with a ponytail, well, at that point, you've already got an interracial couple.
Yeah, you don't do that again.
So you then don't have to go, well, what's the likelihood of an interracial couple in a car?
Plus, if you've got a yellow car and they're in a car, that's the same thing again.
Yeah. So there's a lot of conditional probabilities here where actually some of the earlier conditions have already been met or just aren't being used properly. But the other one as well is basically a sort of a flipping of probabilities. And there is an assumption that if 1 in 12 million couples is like this, then there must be 1 in 12, and we know that a couple that did this was that fit this description were the criminals. Then this couple must have a 1 in 12 chance of being that couple, and that's not the case. Like it doesn't flip. It's like saying if you won there's a 1 in 200 million chance of winning the lottery, and you've won the lottery, then there's a 1 in 12 million chance that you've won the lottery. No, you've already won the lottery. Like it doesn't flip. And
it reminds me of when you get those sort of statistics they do with sort of creationist arguments, where they're like, they say, oh, there's a 1 in a billion chance of things turning out this way, and you're like, well, no, they turned out this way. There's a 1 in 1 chance they turned out this way.
That's exactly it. It doesn't flip. Like, in the case of like you're interviewing a millionaire with a 1 in a lottery winner, it happened. Like the percentages at this point don't really play. Like it's not after the fact. And so, actually, I see that, Andrew, you've dropped 100% of Cambridge Skeptics have a beard and a mustache. It's strange because, like, my last point is how we present.
Does that mean there's a 1 in 3 chance I presented this talk?
So here's a question. Like, there are usually 4 of us on the live stream. Erica can't be here tonight. So 3 out of 4, or 75% of the kind of the Skeptics live stream team are here tonight. If Erica was here, would that be an increase of 25% or 33%?
You go for one, I'll go for the other.
I mean, my instinct says 25, but yes, I see what you mean.
Mine says 33. My instinct says 33, so I'm going for that one.
And like the answer to this is really, really, it depends. It really depends on how you're presenting it. No, it's important because, let's say we're talking about teen pregnancies. Let's say that 0.1% of under 16-year-olds get pregnant, and that in 1 year, and then the following year it's 0.2%. Is that an increase of 0.1%, or is that an increase of 100%? And it really does matter whether you're presenting it as a number or as a percentage. Because I would say it's a 25 percentage point increase, or it's a 33% in numbers. The number of Cambridge Skeptics increases 33%. The percent of Cambridge Skeptics increases 25%. So similarly, with the teen pregnancy, it's a 0.1% increase. There's a 100% increase in the number of cases, yes. This is a 0.1% increase. It's like the proportion of kids that are getting pregnant is still really, really small.
This is one of those ones that definitely comes up with sort of vaccines a lot. It's like, if you or in the Daily Mail, sort of things like this will cause you cancer. If you eat croissants for breakfast, you have a 100% increased chance of getting cancer. But you actually look at the numbers, and it's you have a 1% chance of getting cancer out of 100 if you don't eat croissants, and a 2 out of 100 if you do. So it's actually just a 1% increase, but you can frame it as a 100% increase in actual numbers.
Yeah, it's so and it's kind of going back to the earliest point, which is actually the issue isn't the statistics, the issue is the presentation, and people are all a lot of people will just build the most sensational headline. It's the thing that captures attention. It's a lot of particularly a lot of news companies will have a separate person do the headline and like the initial blurb to get people onto the site. Then the person actually wrote the article, and you never see nuance.
I think Sheldon's got the right answer to your question there, Sam.
Yeah, I'll stick with it.
Definitely true.
Yeah, thank you, Sheldon. And yeah, so it really is. Yeah, there are a lot of things to look out for, I think, in statistics, but the main thing really is the presentation. It really is. You can have the best evidence, the best process in the world, but if it's not presented in the right way, it doesn't mean anything. And I'll remind you actually of something I think I sent on to our group chat, which was just I guess it's a meme, which is, scientist, my discoveries are meaningless if taken out of context. Headline: scientists say discoveries are meaningless. It's that. It's that's it. And that was also everything I had to say. So well done.
So have you got any tips for us to spot these tricks when we're going through the Daily Mail for some reason?
Number one, don't go through the Daily Mail. Number two, if you look at someone else's, it really depends whether you look at your own data or someone else's data. If you look at someone else's data, inspect the axes. That's your biggest giveaway usually, and then also inspect the groups. How is the data being presented? Is it being presented honestly? If the axes don't make sense, that's fine. If they are logarithmic, then they should be labeled as being logarithmic. You should be aware of that, and you should consider that when you're interpreting them. Sometimes it's an appropriate way to visualize things, but if you have a look at it, even though the number of cases over the course of the pandemic has generally varied from several hundred a day to hundreds of thousands a day in the UK, they still use the same axis, and they don't use logarithmic axis. They use a ordinal axis, and that's because that's the best way of presenting the data. Yes, it's a little harder to read across and see exactly what the number is, but in terms of getting the right gist, getting it being presented honestly, that's right. So unless you really, really need a logarithmic scale, I'd steer away from it. If it's your own data, plot it in 2 dimensions, plot it in 3 dimensions if you can group it as well.
And if we discover any new dimensions, we'll put it in those as
well. You can do 4-dimensional graphs if you want to. It's a pain, but you can do it. Just interrogate it. And if you do think you see a relationship, if you can't think of a reason why there's a relationship, there probably isn't one, or at the very least, you need to come up with a reasonable mechanism by which
Nicolas Cage movies.
Yeah. Where is Nick Cage in the equation?
Yeah. Have you remembered to take him into account when calculating your graphs?
Yeah. I think that's
cool.
I think that's it.
Well, just seeing if there's any questions. If anybody's got any,
a little bit of lag between what we have and what people put up. But in the meantime, do you want to talk about what's happening next time?
Oh, yes. So do you want to bring that up? Yep. Yeah, so next time we have a guest speaker.
Is it Nicolas Cage?
It's not Nicolas Cage. It's Dr. Phil Chadwick, who I must say did provide me with this picture with the thing on his face. I didn't just randomly find that on the internet.
Is that some sort of 5G effect? Or?
Apparently, I think he was in some African country somewhere. He said he did tell me. But yes, he's going to be coming in to talk to us about 5G misinformation, and so probably things like conspiracy theories and is it responsible for COVID and stuff like that, and explaining to us why it's not, basically. why 5G is not something we need to all be worried about and start wearing tinfoil hats for.
Because 6G is coming.
Yes, because 6G is coming, and that's the cause. Yeah, that's going to be the problem. So,
and I'm curious to know if tinfoil hats would stop 5G.
I think that's a question for Dr. Phil Chadwick.
I think so.
Yes.
I think so.
So, all tune in next time and ask your questions about tinfoil hats. I probably should have remembered to bring up the information about Dr. Chadwick. He works with he's a doctor of electromagnetic frequencies, and so he knows what he's talking about. And runs an organization that basically talks about misinformation and getting information out there about what these frequencies and stuff do to people, or don't do to people, as the case may be. So yeah.
Oh, and I think as well, he wasn't he president of or former chair of the electromagnetic something. I remember looking up.
Possibly, I didn't remember to load up that information before we went.
Professionalism.
Yes, that's we always do so well in this show. Yes, but yeah,
we got a question, by the way.
Yeah. So much question: how is Simpsons Paradox the bane of my life? It's not so much that it's confusing me. It's that, well, I suppose two things, which is it comes up more than you'd think, and it can present an issue in modelling, because if you don't have access to I mentioned that my own definition is that sort of the relationship between A and B can seem opposite to what you would expect because of a third variable C. Well, if you don't have if you're trying to build a model and you don't have access to C, well, actually it will try and build this wrong-headed relationship between A and B, particularly if one of those is the dependent variable that you're modeling on. But also, even if you do have access to C, sometimes C has another relationship with one of them, or sort of has it just confuses things. It makes it really difficult. And so you've had some really odd things. And I mentioned I work in insurance. We've built models where the relationship seems to be that demand increases with price, i.e. the more you increase the price, the more likely someone is to buy a policy, which, let's be honest, we all know isn't true, and that's because of relationships with third variables. So that's a problem. Also, we have execs that have access to like BI tools, but they see things and then they go, we should do something about this. Do blah. And you're like, no, blah's a bad idea. We need to do the opposite of blah. Because
it's not so much Simpsons Paradox as the bane of your life, it's more executives.
Yeah. Well, I have a whole other executive paradox, but well, not executive paradox, an executive fallacy. But I'm not going to go into that. It's it's basically similar to like the I forgot what the name of the other fallacy is, but basically like, oh hey, if I did something and then something I wanted to happen happened, then the thing I did must have caused whatever happened. Is like, no. It's sort of a bias to action kind of issue. Actually, no, it's basically that an executive will believe whatever they need to believe in order to be able to hit their targets.
Sounds about right.
You're like, no, this doesn't make it. There's no evidence for this thing existing. Like I've had them come up to me and say, yeah, well, our sales are going to increase next month. Why? We're not changing our prices. Yeah, but we're not going to hit plan otherwise. Like, yeah, I know we're not going to hit plan otherwise, but you can't just wish. Anyway, sorry. This will turn into a 40-minute rant about why execs are wrong-headed sometimes.
Anyway,
yes, bane of my life, because
I thought we were going to get through one without Sam having a meltdown, but
no,
Sam, tell us how you feel about koala bears.
Koala executives.
Oh, don't even stop me. Well, both have a very high rate of chlamydia. No, I don't know. I have no idea.
Should we take Phil's picture off the screen before he gets associated with this?
Sorry, Phil. So that's our show for this week. Thank you very much, Sam. That was really interesting.
Is that causation or correlation? Chlamydia and executives.
So yeah, tune in 2 weeks' time when we're going to be looking at 5G misinformation with Dr. Phil Chadwick, and we look forward to seeing you all then. Okay, we'll sign off before this gets any more out of hand. So
we'll carry this on in the private room.
Yes.
Bye.